Now, the first section is section 1.1, and that was when I introduced you to what imaginary numbers were, and we started simplifying radicals. So the first thing I want to go over with you is this. So this is what I want you to jot down. And again, this is from section 1.1, the section 1.1 review. Can you guys see my screen, my handwriting? Yes, thank you. All right. If I ask you to simplify the square root of 192, we have to find the biggest perfect square that goes into 192. And I do not know that. I do not know that. I've got to find my factors of 192. And you can use your calculator for this. So I want to remind you of how to do that. So if you have your calculator with you, go ahead and grab it. If you don't, I have a few extra you could borrow. You just need to let me know. Now, you can just sit here and do 192 divided by different numbers. You can. But the trick is you go to y equals, and I'm pointing at it right now at the bottom of your screen, y equals. And whatever we're trying to find the factors of, you type that number divided by x and y1. Yes, you need one. Oh, you've already got the answer. Very good. Yep, very good. So what would the answer be? Radical. That's okay. Beautiful. So I type that into y1, and then what I do after that is I hit the second key, the blue second key, and hit graph. And that takes me to the table. So my table's out of whack, so I'm going to change my table start. Okay. Oh, it's not starting there. My table start. Oh, it's starting at 60. I'm going to start it at one. Okay. All right. So 1 and 192, nope. 2 and 96, nope. Oh, look, that's exactly what Timmy just said. 64 is a perfect square in 3. So that's the set that I wanted to find. So 192 breaks into 64 and 3. And then this is the biggest perfect square. So I'm going to take the square root of 64, and that is 8. So that comes out of the radical. And then under the radical, I have a 3. And that would be what I would type in the Delta Math. Okay, now what about this? I have the square root of negative 200. Now remember, on one of your note cards, you're going to see this. I is equal to the square root of negative 1. So this is really written as the square root of negative 1 times the square root of 200. And what is the square root of negative 1? It's I. So this is where I would have said to you that first week of school that it would be, you have a negative, you pull out an I. Now, 200 breaks into what? That's right. So I pull my I out, that takes care of the negative, and then I simplify like we did up here with the 192. So 200 breaks into 102. Square root of 100 is 10. So where do I put that? Do you remember? This was the first week of school, so it may be a little bit that. So, but you have an I there. There you go, 10I, and then radical what? Yep. There you go. And that was the very first section 18 weeks ago of this semester. There was a little bit more in that. And I'm just going to do one subtracting and then one multiplying. Okay, so this right here is a binomial. It's called a complex number. It's an a plus bi form. So I have a binomial minus another binomial, another complex number. And you're just going to be asked to simplify this. So what would I need to do to simplify this? Remember, you just treat the I as an X. So what would I need to do? I would need to distribute the negative to the right side. And then you simply combine like terms. So in the green, what would I get? Okay, that would be the blue, but yes. What about for the green? You're good, you're good. So it'd be minus 16 minus 13i. So yeah, if you're asked to add these, you simply just add like terms. If you're asked to subtract them, you distribute the negative and then combine like terms. The next thing you could be asked to do is multiply. And this is when students started getting problems wrong. So if you're not writing these down, this is one that might be a good one to really pay attention to. And on the side, I want you to write this because this is on a note card and it's super important. And that is the reason why a lot of students missed it. Because they forgot to, in the place of I squared, put a -1. You might be going, well, Miss Sharp, there's not an I squared right now. Well, there's not. But when I go to distribute, I'm going to get one. So I'm going to distribute the 4. That's 4 times 1. 4, yep. And then what's 4 times -2i? Yep. And then I'm finished distributing the 4. Now I need to distribute the 4i. 4i times 1 is 4i. Okay, and here's where things started going a little haywire for probably about 30% of my students. What is 4i times -2i? Say that again. Yes, good. So minus 8i squared. That's right. Because 4 times -2 is -8, and I times I, remember, you just treat I like it's an X. So if it were X and X, you put X squared. Now, the reason why students got this messed up, I remember the specific question on the checkpoint is they cleaned up the middle part and they left it like it was, and there was an answer choice like that. It just wasn't simplified all the way because what is I squared? Right, so in that I squared spot, I have to put a -1. Because I squared is -1. And so what happens is, what's that last term turn into? That's right, a +8. And then you just combine like terms. With imaginary numbers, you are not simplified until you get rid of the I squares. So those two go together. And these two go together. And remember, you write them in A plus BI form. So you put the real component first. So 4 plus 8 is 12, and then minus 4i. That's your longest section of today's assignment. Okay, now the next part is section 1.2. And this is where we were solving quadratics by taking square roots. So let's just do one of these. So let's write this one down. My goal here is going to be to get this by itself. So what do I need to do first? Okay, now I can't distribute the 3 because this has a square on it. That ruins that. Normally you would, but because that has an exponent, we can't do that. Okay, so add 17. Okay, so remember, we need to get this by itself. We're closer, but we're not there yet. So I added 17. What now? Not yet. I don't have the green box by itself yet. Divide both sides by what? 3. So now I have this by itself equal to 4. That's when I square root. That's what section 1.2 was on. You get that binomial squared by itself, and then you take the square root. So I take the square root of both sides, put a plus or minus here on the right side. Now what do I get on the left? Yeah, and that's why we do this. Good. We get x minus 5 equals plus or minus 2. And again, here's where I'd have students get here, like they would do all the work, and then they wouldn't know what to do now. Like they would get here, they do all the work beautifully. What do I have to do now to solve this? Okay, so just ignore this for a minute. How would I get rid of a minus 5? Add 5. So I'm going to add 5 to both sides. So I get x equals. Now, what you would do here is you'd put this in front of the plus or minus. So a positive 5 in front of the plus or minus. Yeah, and then we do the add and subtract, right? We do, oh, this is 5 plus 2, and this is 5 minus 2, and we figure out what that gives me. 7 and what? 3. Good. And so on Delta Math in this section, you have to go hit the little plus, and it's going to give you those squiggly brackets and make 2 answer places. So it would be this and this, and it wouldn't matter which one you wrote first. So that's the 1.2 side. And then the next thing I want to go over is solving by factoring. That's the 1.3. We're about done with me going over stuff. I just want to make sure you understand it before you start doing it. So 1.3 was solving quadratics by factoring. So this is the one I want to do. X squared plus 20x plus 72 equals 3x. Now, if I tell you to solve this by factoring, anybody know what the first step would be? Yes. Yes, you have to subtract the 3x because you've got to get a 0 on the right side. Good. All right. Now, this A is 1, so it's not really one of those really difficult ones. But we go, what times what is 72, but adds to give you 17? So when A is 1, you can do it like this. And if I remember right, you guys told me Miss Kane did like an asterisk method or something like that. I didn't do that. I just, yeah, 8 and 9, good. And guys, if you don't know your factors of 72, you can do that little trick I showed you earlier. But does that work? What's 8 times 9? Yep, and then what's 8 plus 9? Heck yeah. So now once you figure that out, you factor with those factors you just found. And then you do the zero product property. I call that ZPP. So you set each of these factors equal to 0. Guys, I'm showing a bunch of extra steps. We got to the point where you didn't need to show all these little steps, but we are reviewing, so that's why I'm doing all these extra steps. But what would I get right here? Good. And what about here? Yeah, so there's your answers. So in Delta Math, you'll have to hit the little plus to get the squiggles. And there you go. All right, and then lastly, we are reviewing 1.4 today, and this is the quadratic formula, but it was with pretty answer. Well, no, it was, well, pretty, yeah. Meaning it could still be a fraction, it's just no irrationals, meaning the discriminant is a nice, pretty, perfect square. This is the last one I'm gonna do. 2x squared minus 7x minus 18 equals -3. And I want you to solve this by the quadratic formula. And guys, I think that's note card 24. I am going to write it out for you. But you've got to get it set equal to 0 first. So you add 3. And you pull off your parameters. What is A? 2, good. What is B? -7. And guys, anytime B is negative, teachers know that the chances of students getting it wrong is going to raise exponentially because of the formula. So if you don't remember it, I'm going to show you. And C is -15. So the quadratic formula is x equals -b plus or minus square root plus or minus square root b squared minus 4ac, b squared minus 4ac all over 2a. Okay, so there it is. So now we simply take these and we plug them, the parameters, into the formula. Remind you of a cow. I had somebody tell me the formula reminds them of a cow. Tell me why. Do y'all see it? Does it look like a cow? Is the eyeballs? Are these the eyeballs? In Spanish, it's vaca. Oh, because of that. Got you. Okay. I was trying to see a cow face or something. Okay, so then I go x equals. Now here's where students mess up. What's the first thing in the formula? Negative what? B. And what is our B? -7. So what's going to happen? It's +7. That's right. So that's a +7. And then plus or minus right here, when your B is negative, what is -7 squared? Right, it's a +49. So +49 minus 4ac. So I'm just going to put all that in. But when the B's are negative, we got to be super careful because students will actually type it in wrong and it'll give them wrong signs and they'll get the wrong answers. Now, I don't know if you remember, and hopefully if you look through your note cards, you'll be reminded, but when we did this, I had a sharpism. A lot of stuff I've taught you are sharpisms, the way that I recommend you do it. Not other teachers might not say this, but the way I recommend you do that is you just type in the green, just the green, not the radical, just the green. So you get your calculator and I hit second quit. Gosh, it's hard to see this. Maybe that's better. I don't know. All right, so I'm just typing in, oops, what's under the radical. There we go. That's called the discriminant. And I get 169. Did you guys get that? Okay, so then I go here. And this lesson is, these are always going to be perfect squares. What's the square root of 169? 13. And that doesn't always happen. Sometimes it's negative, sometimes it's not a perfect square, and we're going to look at that tomorrow. Now, once I get here, you do this. The plus and the minus of it. It's going to be 20 over 4, just 5. And then this one, negative 6/4, which is negative 1.5. So my answers are 5 and negative 1.5. So on Delta Math, I'd have to hit the plus to add another space for my answer. And there you go. That's a review of the quadratic formula. And guys, you probably remember it, but it's not going to hurt to go over it again.